Hey there! It's a pleasure to have you here as we dive into the world of sets in Python, specifically tailored for IT freshers like you. Python sets are a fascinating data structure that are not only unique in their nature but also in their behavior compared to other collections you may be familiar with, like lists and dictionaries. Sets are specifically optimized for membership tests, operations that yield items that are not in the set, and set operations like union, intersection, and difference. If you've ever found yourself trying to see which elements are common between multiple datasets, the set operations can be game changers, making this process incredibly efficient and straightforward. Let's start by understanding what sets are, where they fit in the Python standard library, and why we care about them. Python sets are a built-in type in the language, derived from the mathematical concept of sets, and they come in handy when dealing with a collection of distinct objects. As you are likely aware, Python lists are ordered and can be duplicated, whereas sets maintain no order and no duplicate elements, which is something special that sets do that can save you time and computation. Let's talk about set creation and elements. To create a set in Python, you simply initialize a variable as an empty set or use the set constructor like this: my_set is equal to set or my_set is equal to 1, 2, a, b, for example. Note that lists or dictionaries can't be directly turned into a set because they aren't hashable, but that's a detail we can address later on, with some exceptions. Sets can be modified, accessed, and manipulated in various ways. You can add an element to a set with the add method my_set.add or remove an element with remove or discard my_set.remove or my_set.discard. However, if the element isn't present, discard raises no error, unlike remove that does. Apart from adding and removing items, sets in Python can perform several mathematical set operations and come with built-in methods to help solve complex problems related to data. For instance, union merges to sets, while intersection or and provides common elements between sets. Think of it like finding a match between two groups of people's names to see who attended to different functions. Then you've got difference, or to find items within one set that aren't in other, and symmetric difference, or is equal to find elements in either of the sets but not in both. Now imagine you have a list of words, and you want to know which words are not common between two different documents. You can use sets to make this process quite seamless. Also, Python sets are great when storing elements, when order is not essential, and speedy for checking if an item exists in the collection. The speed here is crucial in big-scale data processing, where speed is money. But the benefits of sets don't stop at the mere execution of set operations. Sets are iterable, and they can easily be looped through with a for loop, akin to how you traverse a list, giving us straightforward ways to iterate over our distinct elements and carry out actions for each element that we find. Another practical application is the use of sets as keys in dictionaries. This might sound a bit advanced, but it's within reach once you grasp the basics of sets. A set can be hashable when it's made up of hashable and immutable data types only, like tuple of integers or strings, making them perfect for use as dictionary keys. One more trick up Python sets sleeves is intersection_update and difference_update, which modify the set upon which these methods are called, making the operations very efficient. Understanding sets is key not just for solving problems today, but also for making more informed decisions about your data. Knowing when and why to use them can greatly speed up processes and optimize memory usage, a real-world skill as valuable as the code itself. The intersection of programming with sets doesn't stop at Python, with most programming languages offering some form of set implementation. This universal concept has been adopted by languages like Ruby, Java, and C++ with their own distinct approaches, ensuring that even in cross-language development, understanding sets will benefit you. Now that you have a firm understanding of what sets are, I hope you are noticing their beauty and power in making your Python coding experience efficient and enjoyable. Remember, Python sets act as a real-time solution when you are working with unique collections, optimizing certain operations and making your code more readable and maintainable. To help you wrap your head around these concepts before moving forward, I recommend exploring Python built-in functions for sets, like union, intersection, and difference, and trying them out on your own coding exerneria. But wait, there's more. We've barely scratched the surface of what sets in Python can do for you. They are pivotal in problems like finding duplicate items, solving common programming problems efficiently, and more. Practice is your best friend, so roll up your sleeves and try writing programs involving sets to solidify these concepts into your toolkit. Whether you are dealing with data processing at scale or simply filtering data, utilizing the power of sets can yield better results in less time. It's about writing better, more effective codes, and as you now understand, sets provide the perfect tools for some programming tasks. And for those of you aiming to deepen your Python skills and knowledge or just exploring more coding-related concepts, I encourage you to visit neeraj.qzz.io and subscribe to TechLab to stay updated with the latest Python tutorials, tips, and tricks that keep up with ever-evolving technologies. Until next time, keep exploring and coding happily.